and welcome to the wonderful world of opposites and charges and confusing addition and subtraction in ions. So, for ions, we're going to change not the number of neutrons like we did when we had isotopes. This time, we're going to change the number of electrons. And this makes things difficult for us because electrons are negative. That's what they are, which means that if I change the number of electrons, I'm changing the charge. If I add electrons, I'm going to add negative charge because electrons are negative. And if I take away electrons, I'm going to leave behind positive charge because protons are positive. So here's our first example right here. You can see that fluorine becomes fluoride with a 1 minus charge because it has one more electron. It receives one more electron when it becomes an ion. So let's do a couple examples here. I got example problems 4, 5, and 6 down here. Let's fill in this table based on these headings up here. We're going to give the ion name, the symbol, the protons, electrons, charge, and then the total number of electrons lost or gained. Okay, so first up is magnesium. Magnesium's symbol is Mg. We know that from our periodic table. Get your table out, and you can see that its atomic number is 12, which means it has 12 protons. That's its atomic number. And we can also see from our periodic table, if you have the one that we made together, if you don't have the one we made together, you can look this up anywhere, that magnesium takes a charge, a known charge, a standard charge, one charge. It takes a charge of 2 positive, which means we can take this 2 positive and put it up here at the ion symbol for 2 positive. And now we get to the tricky part. We need a 2 positive charge on this magnesium ion that gets created here. And the only way to change the charge is by changing the number of electrons. So here we added an electron, a negative electron, and we got a negative charge. So since that's what happened in this example up here, this is the opposite. In order to create a positive charge here, we need to subtract. We need to get rid of. We need to lose 2 electrons to give a 2 positive charge. So 12 becomes 10. And I have then lost 2 electrons. And that makes sense because remember, metals, and magnesium is a metal, all the metals become positively charged. They all lose electrons, every single one. Some lose more than others, but they do all lose electrons. Okay, problem number 5 here. You're not giving anything other than the protons. That's it. But that's all we really need, right? 7 protons is the atomic number, so therefore we're dealing with nitrogen. Nitrogen is what we're dealing with. And as far as the ion name here, remember, nitrogen is a negatively charged non-metal, which means it's not just nitrogen over here. It becomes nitride. We change the ending to "ide," much like fluorine up here changed to fluoride. We just changed the ending. It's just a convention. Okay, so we know it's nitrogen here. We know it becomes nitride. We need to know its exact charge, though. And up on our periodic table, it's in group 15. And all the nonmetals in group 15 take a 3 negative charge. So we can put that there. Okay, now we can put that up here. Now we get to the tricky part. If it starts with 7 positive electrons, and we know we need to give it a 3 negative charge, well, the negative here means we need to add electrons because electrons are negatively charged. So 7 add the 3 electrons brings us to 10, and therefore we have gained 3 electrons. And it's the opposite of what you think. Positive charges, we subtract electrons, and negative charges, we add electrons. Because remember, electrons are negatively charged. Okay, and then the very last one, number 6 here. This is a tricky one because it doesn't give you anything other than the number of electrons and the fact that it lost 3. But that's enough. That's enough because if we look at this thing, if it has 25 electrons and it lost 3 electrons to get here, well, then how many protons did it have? How many protons did it have to start, right? How many electrons did it start with? And it means it started with 28. 28. Because if it had 28, it lost 3 to get to 25. And we are good to go. Now we can look up the element. We look up element number 28. Turns out it's nickel. So Ni for nickel. We can write nickel over here, if we spell it right. And then all we need here is the charge. And it's pretty easy to determine the charge. There are 3 more positive protons than negative electrons. Therefore, it has a 3 positive charge.